Distance time graphs. A distance time graph is a way to visually express a journey or walk, with the distance on the y-axis and time on the x-axis. A distance time graph tells us how far an object traveled and how long it took to do so. Pay attention in this example. In a sunny day, Margaret was on a bike ride. Travel graph shows Margaret's distance from home on this bike ride. How far had Margaret cycled after 50 minutes? Look at the graph. After 50 minutes, Margaret traveled 10 kilometers away from her home. So, after 50 minutes, Margaret was 10 kilometers from home. After a while, Margaret stopped to rest. How long did she rest? We can see that the line is flat between 60 minutes and 80 minutes, so the distance from home did not change. She rested by 20 minutes. How far did Margaret cycle in total on her ride? Well, during the first part, 60 minutes, Margaret cycled 12 kilometers away from her home. After 60 minutes, we can see that the line is flat, so the distance from home did not change. She was stationary by 20 minutes. Then, for the third part on the journey, after 80 minutes, she traveled back the full 12 kilometers to where she began. Then she cycled 24 kilometers. How fast did she cycle in kilometers per minute at the first part? Speed is equal to distance divided by time. In this graph, y change is the distance and x change is the time. The gradient is the y change divided by x change. We can see that the gradient of a distance time graph is equal to the average speed. Look at the graph. X change is 60. Y change is 12. Speed is 12 over 60. Speed is 0.2 kilometers per minute. How fast did she cycle in kilometers per minute at the third part? We will do the same. The gradient is negative. The speed was 0.3 kilometers per minute in the direction towards home. Example 2. The following graph shows a cyclist's journey during a cross-country cycle race. The cyclist takes 45 minutes to fix a serious puncture. How far was the cyclist from the starting point when she got the puncture? Look at the graph. Between 25 minutes and 70 minutes, we can see that the line is flat. The distance from home did not change. He was stationary. The distance from starting was 5 kilometers. How far was the cyclist from the start-finish point after 2 hours? Look at the graph. 2 hours is 120 minutes. The distance is 4 kilometers. Calculate the cyclist's average speed for the first 10 minutes of the race. Speed is distance over time. Pay attention. Time is 10 minutes. Distance is 2 kilometers. Speed is 0.2 kilometers per minute. The gradient of a line is positive if the line slopes up from left to right. Calculate the cyclist's average speed for between 90 minutes and 120 minutes. Speed is distance over time. Look at the graph. Time is 30 minutes. Distance is 3 kilometers. Speed is 0.1 kilometer per minute. Pay attention now. The gradient of a line is negative if the line slopes down from left to right.